Hey everyone, in this video we are going to discuss the problem E of Codeforces round 1103. So let's see the problem. Arseny decided to make his friends Dabir and Igor happy. For this he decided to give each of them an array of numbers of the same length. An array B is called good if its elements can be rearranged so that for all I this condition is true, right? That is each consecutive element difference is equals to 1. Arseny wants Dabir and Igor to be able to play with these arrays. For this, the following condition must be satisfied. Each of the given array is good. If you write one array after the other, the resulting array is still good. Arseny already has an array of length n. He plans to cut both the arrays from A, that is, to choose two non-overlapping subsegments of the same length. Help Arseny determine the maximum possible length of the resulting array. Okay, great. So we are given n and the length of the array and the actual array, and we need to find if we can get two subsegments, non-overlapping subsegments, such that after concatenating the subsegments, it is a good array. So let's see how we can solve this. So let's take an example of this sample test case. So here are n is 10 and this is our given array. So for our optimal case, let's see if we pick this as the first segment and if we pick this as the second segment. So let's call this A1, call this B1. Okay, so after rearranging A1, our good array will be 1, 2, 3, 4. After rearranging B1, our good array will be 5, 6, 7, 8. After concatenating A1 plus B1, our array is 1, 2, 3, 4, 5, 6, 7, 8. So you see that this is also a good subarray. So our maximum length of A and B is 4. So for this case, our answer is 4. And this is also there in this sample. So for a general array A, how will you solve this, right? Let's say A1, A2, A3, A4 up to AN minus 1 and AN you are given. And you need to solve this problem. You need to find the maximum length of the subsegment you can pick such that you are able to get A1 and B1 of that particular length, and the concatenation of those subsegments is still a good array. Okay, so this is simple. What you will do is you will calculate the so for each subsegment, right? For each subsegment, let's say L to R of this array, you will check if this subsegment is good or not, right? And an you will create an array. Let's call this minimum. Or let's for not confusing, let's take any uh, good 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 segment. Let's call it good segment, and this is of length. This is of n plus 1, and what this segment will store is good segments array. Let's write it more clearly. Only take keep the name of this good. So this will store what this will store is this will store the good segments from this array, right? So let's call, and along with the good segment it will also store the minimum value over this good segment. So let's say take M1, L1, R1. This is M2, L2, R2. Similarly. So we have created an array good which will store these tuples, right? What are these tuples? These are actually good segments. L1 to R1 is a good segment and its minimum value is M. So so if you have this tuple, can you find the maximum value of this segment? Its minimum value is definitely stored. The maximum value will be M plus R1 minus L1, right? Yes, this is the maximum value. So definitely if you store these tuples in this array, you are able to find the minimum value and maximum value over this segment. And why do you need minimum value and maximum value? Because you need to find the value of the elements stored in this subsegment. So definitely the value of the elements stored in this subsegment will be m, then m plus 1, then m plus 2 up to the maximum value, that is this, right? So this is the segment. So after storing only these three values, you will be able to get the complete segment, complete good segment. And let's say once you have these, what you will do is you will brute force, what you will do is you will brute force over the length, or let's say the minimum value. You will brute force over the minimum value. So what you will do is brute force over minimum value. For you will run a for loop for m minimum value equals to 1 to n, because our value of the arrays are between 1 and n. So you will brute force over minimum value of m to n. Let's say currently your minimum value is m, right? Mm, let's say your minimum value here is mn equals to I. I is this looping variable. Okay, now you will iterate over this segment, right? Good segments, good segments for this minimum value, and you will, let's say, have li li ri, right? Okay, the L1 R1, L2 R2. Okay, so let's say, okay, and we also don't need L and R, we just need the length, right? So let's say you will iterate over the lengths of the minimum value. So let's say we have L1 length available, L2 length available, L3 length available, and so on. So for each, let's say currently we have the Li. So what we will do is we want to check if we can get two subsegments where A1 A1 is this one, A2 is A1 is this one, and B1 is our the larger value segment. Okay, so we want to check if we have A1 whose minimum value is mn and it is of length li, and also we want to find b1, we want to find b1 such that an we are able to get a subsegment such that its length is li and its minimum value is, what is its minimum value? Its minimum value is mn plus li, right? This should be its minimum value, and obviously its length should be li. Why is this the minimum value? Because you observe that its last value is m plus, uh, please do not get confused by this L and this L. This is the range and this is the length. Okay, so you need a segment. So this definitely exists because we are just iterating over the good segments whose minimum value is mn and its length is li. So we want to check if there exists a segment B whose minimum value is mn plus li and its length is li. So we can definitely check this. We can store this value while we are calculating good segments. We can store this particular value in an array, right? Boolean array, and we can check this in order of one time. So if this exists, then we will say that there exist two segments of length li, af after which concatenating those segments a1 and b1, we'll still get a good segment. Okay, so li is our valid length. So after iterating over all of the minimum values and their lengths, we will take the maximum value of li which is possible. Okay, and this will be our answer. So let's see how we can code this. So see how we can code this. Okay, we have this array. We took this array as input. We have taken an minimum vector. So what this will store is, it will store corresponding to each minimum value, right? While we are calculating the good segments, corresponding to each minimum value, it will store the length, right? It will just store the length. Length is r1 minus l1 plus 1. For this case, the length is r2 minus l2 plus 1. So we have taken a variable mn, we have taken a vector mn which will store for each minimum value its length which exists in this array. Also we have taken a 2D vector boolean vector array, right? It will, what it will store is, it will just store if there exists a segment whose minimum value is mn and length is li, right? If there exists this pair, then we will keep exist of mn comma li equals to true, otherwise we will keep it as false. Okay, so let's first calculate these two vectors. For this, what we will do is, we will iterate over each segment of the array. This we will do in 2D, like n square time. So this is the first uh, starting point of the segment. I is the starting point of the segment. Now let's iterate for the end point of the segment. So for first, our first segment is I comma I, right? So let's also take a visited array. Okay, our visited array will contain the our visited array will contain the integers which exist in this particular segment in which we are iterating. Okay, so for the first, our first segment will be I comma I. So let's mark this value as visited equals to true. Okay, and let's take two variables, maximum and minimum, over this segment. So for I comma I, initialize these with ai comma ai. Okay, and for our first segment is always valid, right? Because if an element if a segment contains only one value, it will definitely be a good segment. Okay, so add this into our this vector, right? So minimum is just taking into account the minimum value and its length. right? So add the length of this segment, that is 1. And also mark exist equals to true. Exist of m and n, this is the minimum value and its length equals to true. Now iterate over the further segments, right? So from j equals to I plus 1 to j less than n, it just iterate. Whenever we encounter that this value already exists in our segment, we will break. Why? Because you see that if a segment contains two duplicate values, right, then it is never a good segment. A good segment will always have the distinct values. Otherwise, it will not satisfy this condition. The condition that each consecutive element's difference is 1. Okay, so one thing is true, that this value should not exist in our visited array, right? Visited array is taking the track of the current values of elements in our current segment. Okay, now if it is not there in our current segment, just add it, mark it as true. Okay, and increment our maximum value over this segment. So after marking it as visited, increment our maximum value until it is present in our current segment. Okay, also similarly, decrement the value decrement the minimum value until it exists in our current segment. Okay, now here comes the main important part, where we check whether it is a good element or good subsegment or not. So if our maximum value minus minimum value equals to j minus I, this means that the length of the segment, right? The length of the segment is equals to maximum value minus minimum value plus 1. If it is equal, then we guarantee that this is a good segment. In this case, we will fill these values in our above two arrays. That is, corresponding to this minimum value, we will put its length. Okay, and corresponding to this minimum value, we will put its length, that this good segment, such kind of good segment exists. Okay, once we have calculated these two vectors, we will come to the main part of the problem, where we are going to calculate the maximum length we can achieve. Okay, so first iterate over the minimum values, right? Brute forcefully iterate over all of the minimum values. The minimum values that can take place is from 1 to n. Okay, so let's say our current minimum value is I. Okay, now we will iterate over the lengths which can take in this. So let's iterate over the minimum of I vector. What this will contain is, it will contain the length of subsegments which exist in this array and they are good. Okay, so here L is the length of the subsegment whose minimum value is I. Now we will check if there exists a subsegment whose minimum value is I plus L and its length is L. If it exists, then we will maximize our answer, right? Because then we are able to get two subsegments whose concatenation will also give us a good array. So this will just solve our problem, and simply we will output our answer. So this was our solution. Basically, this is our n square solution, and it passes the given time limits and memory limits. So I hope you got the solution. Thank you.